All right, this is chapter 4, section 1, number 73. They want critical points. They want us to graph this on a graphing calculator and find relative maxes and relative mins, and then find absolute max and absolute mins. So all those, a lot of stuff going on this problem. So great problem. So first we need to find the derivative. You should see quotient rule. We have a high and a low. So we need to apply the quotient rule to this problem. So quotient rule, low d high, the derivative top is -1, minus high d low all over low squared. Wow, there's a lot going on here. A lot of factoring, a lot of algebra. Again, the good news, typically there's not this much algebra in an AP test. But for you guys, for homework, awesome practice. Don't avoid these. You guys need as much practice as you can get. All right, let's keep going here. Now we have to simplify. So I need to distribute that negative here, here, here. And then I have to do all this. So I'm going to do all that next. Negative x squared minus 2x plus 3 minus, now I'm subtracting all of this, so I need to have this next blob in parentheses. And that's all over. And I'm going to do something with the bottom too. We're doing a lot of crazy stuff. So we're going to factor the bottom, and it's still squared. All right, distribute. I'll do colors. This, that's going to get me 10x plus 10. Then I'm going to distribute that and that. That's going to get me minus 2x squared minus 2x. In the bottom, this factors, I hope, we'll see if it does, x and x. So the reason, those two must equal the first. And then these two must equal 3, and the only way I get 3 is 3 and 1. So I know that's good. Now, these must get us our middle term. So that's 3x, that's 1x. How do we get 2x from that? If we subtract 1x. So that's going to be minus, that's going to be plus. And so there we have our factoring of the bottom. And just to double check, x times x, x squared. Perfect. Positive 3 times -1, -3. Perfect. 3x minus 1x, 2x. So now we have everything set up like it should be. Now the top can be simplified more. I have to distribute this. Actually, yeah, we'll distribute first, then combine like terms. I probably should have combined like terms first, but not that big of a deal. Minus 10x minus 10 plus 2x squared plus 2x. All over, and I will write this like this now. I'm just squaring the whole bottom. This is crazy. A lot of algebra. So the only calculus we did was that. All of this has just been algebra so far. Let's keep on doing algebra, combine like terms. Minus x squared and a positive 2x squared. That's going to get us a 1x squared. So we're good with those. Then we have the x's. So we have minus 10, minus 2, that's minus 12, plus 2. Well, those are going to cancel, leaving us minus 10x. And then we have minus 10 plus 3, that's going to be minus 7. A lot of stuff. We're not done. Well, I think we are done. I don't think that top is going to factor for us unless I did something wrong. Let me double check because that's not looking that pretty. Well, I guess we're right. Okay. Now, this is the derivative. This is h prime of x. Now we're asked to find the critical points, and here is here's what a critical point is. It's where the values of x where the derivative is 0 or does not exist. When is a fraction equal to 0? If you have trouble with this, you need to settle in your mind and be comfortable with this, or it's going to bite you on a test. When the numerator is 0 a fraction 0. When the denominator is 0, a fraction does not exist. So those are the points we're looking for. So we're going to set the numerator equal to 0 and the denominator equal to 0. Well, this one's easy. You set each factor equal to 0, and you get -3 and 1. So those are two of our critical points. Now, this is not factorable. That means we have to use the quadratic formula. There once was a negative boy, and you don't have to use a quadratic formula in AP test, but you should know how to use it, who could decide whether to go to radical party. Because he was so square, he didn't go and missed out on 4 awesome cookies. There were really good cookies at this party. The party was all over at 2 a.m. Well, I'm not going to do all the fancy schmancy work for you, but this comes out to be 5 plus or minus 1/2 the square root of 128, which is 5 plus or minus 4. So you have to be able to work with radicals. 4 radical 2. Which means this is actually 2 different answers, or 5 minus 4 radical 2. I don't need the parentheses. So we have 4 critical points. So we have done part A, find the critical points. Part B, we have to graph this. I'll graph this on a graphing calculator after I do part C. Part C is asking for the absolute max and min, I believe. Let me read this, 73. Find the absolute maximum minimum values on the given interval if they exist. So actually, a couple things are going to happen here that you have to see. If you were to graph this function, there are vertical asymptotes. And so I guess I probably should graph this and show you why we do what we do. So let me stop sharing here. And I'm going to start sharing on my screen. So let me stop this. And I'm going to share here. So you should be able to see that screen. I'm going to put in the function here. Y equals, that's not happening yet. Y equals, on top, I'm going to have a 5 minus x divided by, then we have x squared plus 2x minus 3. There's our graph. And if you see on this graph, we're not going to have a max or a min, and our domain is -10 to 10. Let me add that. Our domain is -10 to 10. So there's our graph. Clearly, there's not a max or min because it goes up forever. There's asymptotes. That means it goes to infinity, negative infinity. So part C, you will not have any maxes or mins on this. So remember, the extreme value theorem says if you have a continuous function on a closed interval, you will have a max or a min. But this is not continuous. You have vertical asymptotes. Therefore, you don't have to, and in this case, we don't. And that is the end of this question.